Okay, in these last examples here, we're going to have a little bit more work to do, and we're going to have to rationalize some denominators and do some different things. So let's set up those special right triangle templates first before we get started. Okay, so now that we're set up with our 45, 45, 90, and 30, 60, 90s, we are ready to roll. So let's go ahead, and I'm just going to go ahead and put all the matching sides in real quick here. So we know the 7, that hypotenuse is going to match this one, and this leg is going to match that one, and it appears this last guy is going to match over here. All right, so let's write down everything that we know so we can start solving, chasing that n variable around and finding out what these remaining sides are. So we got the n square root of 2 equals 7, and then I have n equals w, and then I have n equals y. Okay, so the first statement appears that is the one that only has one variable, so we're going to go after it. So to do so, we're going to go n square root of 2 equals 7. So I'm going to divide each side by the square root of 2, and in this time, on the right hand side, it's not going to go out. And as we've seen, and when I say go out, it's not going to cancel out. It's going to be stuck in the denominator there, and we have seen that when we have square roots in the denominator, they need to be rationalized out. So I have n equals 7 square root of 2, but we don't want it to leave it like that. So what I'm going to do is that I'm going to use our rationalization technique, and we're going to multiply the top and the bottom by the square root of 2, and we're going to find out that n is going to be 7 square root of 2 over 2. And so now I can plug that in for the other for the other variables to solve for, or for the other n's to solve for w and y. Okay, so it looks like w is going to be 7 square root of 2 over 2, and as well, it looks like we have y is going to be, so putting that in for n, is going to be 7 square root of 2 over 2 as well. And so putting these all, well, I'm just going to draw the lines to them, and so it looks like we solved out those guys pretty nicely here. Okay, so remember is that sometimes there is some work to be done after you solve for n, okay, and plugging them back in. Sorry for all those arrows there, but anyhow, that's how you do that. So let's start knocking this this next one down. And so I'm going to start matching the sides like we have been. 10 matches up with n square root of 3, and we have w down here is going to be n, and then we have y equals 2n. So that said, is that we start to put all the information together, and again, if you follow these steps, okay, then you're going to just end up with really organized information. You're going to cut down on your errors and, heartache of having to redo stuff down by a lot. So, all right. So here we go, and then we got n equals w. Okay, so everything's matched up, and the first one right here, it appears that is the one with only one variable, n. So we're going to do the same song and dance, and I'm going to just put this down here for now. And I'm going to go n square root of 3 equals 10. Divide by the square root of 3 to go ahead and free up the n. And now I have n equals 10 square root of 3. Divided by square root of 3, sorry. And so what I want to do is I want to multiply the top and the bottom by the square root of 3. And that's going to give me 10 square root of 3 over 3. Okay? And so, there we go. It's all rationalized out, and now I can plug this back in and start to solve for the other stuff. So here we go. I'm going to get y equals 2 times 10 square root of 3 over 3. And so at the end of the day, y is going to give me, I multiply the 2 and the 10 together, and that's going to give me 20 square root of 3 over 3. And then we have w down below, and w just equals n, and we already said that n is going to equal 10 square root of 3 over 3. And so, yeah, that's how you go ahead and use these special right triangles all the way back from discovering the patterns and then taking those patterns and using them to solve out sides, even when we have just one side in the Pythagorean theorem. So that's one thing that I want to go ahead and wrap this this kind of like video session up with, is that one thing that we've done is that we don't have to use trigonometry, which we're going to be using in some future videos, to go ahead and solve for sides of a right triangle where we have two unknown sides rather than just one unknown side where we would just use the Pythagorean theorem. So that's a pretty big deal. Okay, so that's how you do that, and yeah, I will see you in the next videos.